Okay, I texted her, so
Yeah, they do. Basically, if it flies, they make it.
Pull
Watch them make a bird.
I might not be able to talk too much today, and that and lots of background noise, so I apologize for that.
Okay. No worries.
Okay. Well, let's just go for it then, you guys.
Okay.
I'm just gonna start reading through. Because I know we're supposed to do number 5 together, but let's just talk about the first 4. So number 1, what are the 3 chemical components of a nucleotide? So, and I just have the key in front of me, so
Oh, dang it.
What?
Okay, sorry.
What?
Sorry, never mind. It's not important.
Oh. Okay, so 1 to 3 phosphate groups, a pentose sugar, either ribose or deoxyribose, and a nitrogenous base. So,
Yep.
it lists the ones from DNA and RNA. So, and then the next part of this is what are the functions of the following carbons in either deoxyribose or ribose? So the 1' carbon of both ribose and deoxyribose is attached to the nitrogenous base. 2' of ribose is attached to a hydrogen atom and to a hydroxyl group, and the 2' carbon of deoxyribose is attached to 2 hydrogen atoms. It says what is attached to the 2' carbon distinguishes DNA nucleotides from RNA nucleotides. And 3' is attached to a hydrogen and a hydroxyl group. Says the 3' carbon is extremely important as it serves as a site where a covalent bond is formed between the incoming nucleotide and the existing nucleic acid strand during deoxyrization. 4' carbon maintains the ring structure of the pentose sugar, so doesn't really do anything. And then the 5' is attached to a phosphate group, and the phosphate group functions during DNA replication and transcription. A covalent bond is formed between the 5' phosphate group and the incoming nucleotide and the 3' hydroxyl group on the existing nucleic acid strand. That was a lot.
Yeah.
Makes sense. And, well, I guess this is the next. Or that would be the next. I was gonna say like the different bases, but
Wait,
that's
so just the carbon just the most important?
What?
I think it's enough to like slide your book all the way down.
Okay.
What,
Shannon?
what'd you say, Shannon?
I said just as a curiosity question, is the second carbon one of the most important out of 5? Like, I know they're all important, but if we had to choose one, is the second carbon the most important?
I would think so, because it's the one that tells us whether it's RNA or DNA, right? Or no, yeah.
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 But
So
it
it
says
is. So I just.
but the 3' carbon it also says is really super important because it allows
Okay.
for the DNA to replicate and transcribe.
Okay.
Yeah, because isn't
I'll keep that in mind.
the 3' carbon isn't that the one that like attaches so that it can get unzipped?
It's the primer. It's like, right?
Oh yeah. Yeah.
So like,
Where like RNA primase or whatever attaches.
and unzips like 3 to 5 and since that's 5 to 3.
Yeah. Okay.
So things are attached after 3, right?
Yeah.
I don't know why I'm using my hands.
It's okay.
Anyways. Should we go? Does that make sense? Yeah?
What? What?
I said, are we good there? Should we go to
Yeah, I
2?
think so. Yeah,
Yeah,
let's do
yeah, we're good. Sorry, move on.
I'll read 2. This question concerns the structure of DNA and chromosomes. I don't have the key yet, but what are the 4 nucleotides that can be used for RNA synthesis? Please write the entire name of each chemical. I put guanine, cytosine, adenine, uracil, right?
It says on here that it wants adenosine triphosphate, guanosine triphosphate, cytidine triphosphate, and uridine triphosphate.
Yeah, it's like the full-on thing.
Dang
This
it.
section.
Yeah, that's what I got wrong too. That's why I pulled up the key to check it because I was like, that sounds too easy.
So those are like,
No, because I knew it had to be a phosphate in it, but what's the difference between writing like monophosphate or diphosphate or triphosphate? Because in the example, it only listed like one monophosphate and then it listed as a triphosphate at one point. But then the key was like all triphosphate,
I think
and I
it
couldn't
just
find it
depends
reading
on how
like
many
where it says.
phosphate. Because I think that just kind of gives
What do you mean?
okay, it's supposed to be 1 to 3 phosphate groups. So they can have 1 phosphate or 2 phosphates or 3
matter.
phosphates. So I don't think it
No,
really
no, that
matters
I
on that
knew. It's
point.
just like no, but like in this specific problem, like for RNA synthesis, how do we know it's specifically triphosphate?
I don't know. The
That's
other
what I
thing,
got confused on.
I'm also confused because like adenosine triphosphate is ATP. Why is adenosine triphosphate more important than any of the other triphosphates?
Because ATP is used for like everything.
But why is it that's used for everything? Why can't it be another nucleotide?
I don't know.
And that's why I'm confused. 'Cause I'm like,
Because
it's a
it's letter
special.
A and A is awesome. I don't.
That's
Well,
literally the only thing I can think of.
because I don't know. I really don't know what I'm saying, but like, you know that adenine and like the A2 rich regions, they form weak bonds. So maybe that's why it's because adenine triphosphate forms weak bonds with things, so it's able to like allow it's like more available for things to react with it, so it can make things happen.
Oh, okay.
Now you know what you're asking.
What?
I could.
What?
Can you hear me?
No, your thing keeps freezing.
Oh,
Oh,
sorry.
fine. I don't
I
know.
said maybe because like adenine, you know that like A2 rich regions. I think that adenine just forms weak bonds with things. So in like the body or whatever, adenine probably forms weak bonds
Okay.
and it allows like it's more available for things to react with it to make things happen in the body. Or
Okay. That makes sense.
that's just a guess.
Okay.
But so that was wrong on my side too. B is what are the 4 DNA nucleosides? Please write the entire name of each chemical. So nucleoside is just a base and a sugar, right?
I don't know. Is it?
I think so.
This one's
Or if
still
it's
one where
deoxy.
like it's just named the 4 bases kind of
So
thing.
just be adenosine, guanosine.
The key says it's deoxy, adenosine, deoxy, guanosine, deoxycytidine, and deoxythymidine.
Okay, that makes sense.
Yeah.
Yeah, it's because without the deoxy, if you just leave it without it, then it's just RNA, and so therefore the answer has to be literally deoxyguanosine, which is stupid, but
Okay, that makes sense. C is suppose the genome of a newly discovered species of bacteria contains a double-stranded DNA molecule composed of 24% thymine. What percentage of the genome is composed of guanine, cytosine, uracil, and adenine? So I said 24% adenine, 26 guanine, 26 cytosine.
Yeah. And no
So how
use.
did you get the percentage to be exactly for 26, 26 cytosine and guanine? Because is it just based off of pairs?
Yeah,
Yeah.
so you know that like there's 24 thymine, so there has to be 24 adenine because those two pair up and double stranded, and then the remaining
Okay.
24 plus 24, 100 minus whatever that is, divided by 2 is 26.
Okay. Just okay. So even if the numbers were to change, like instead of 24%, say it was like some other percentage, it's just so long as you follow the bases together, and then so long as like the other percentage matches 100, that's the correct rule to follow.
Yeah, if the
So.
bases, if like adenine and thymine are pretty close to the same, and guanine and cytosine are pretty close to the same
Okay,
percentage.
I get it.
Because like in the examples, a lot of them, especially the one like for the individual problems, a lot of them don't match up completely. Like adenine could be 24%. I mean, so thymine's 24%, adenine could be like 28, but you know that it's close enough. I don't know what the rule is there as far as like how far apart they have to be considered like single stranded, but yeah. Are you good there?
What?
I said, are we good?
Oh, yeah. Yeah, I'm good.
Okay. Do you suppose the genome of a newly discovered species of virus contains a nucleic acid molecule composed of 38% adenine, 20% guanine, 35% cytosine, and 7% uracil? What can we conclude concerning the genetic material of this virus? And I said it's a single-stranded RNA.
Yep.
Yeah, that's right.
Sweet.
Yeah.
Who wants to take the next one?
Wait, what did you say? I totally lagged on it.
Oh,
Single-stranded RNA.
So I knew it was RNA, but how'd you know it's single-stranded?
Because RNA is always single-stranded.
What?
why did they have double-stranded RNA listed then?
They do?
I'm wondering.
Yeah.
Yeah, they do. That's why I was
I
super
think RNA
confused.
is double-stranded.
That's what I thought it was double-stranded.
Wait, where does it say that?
On the PowerPoint, I think, or in the notes.
But you know it's not
It was an either or. I saw it too.
because adenine, so adenine is 38% and uracil is 7%. So you know those bases aren't matching up to form a double strand, and guanine's 20, cytosine's 35. So they're not even close to being the same percentage, so they can't match up to make a double strand. So you know that all of those percentages are just on a single strand.
Oh.
Oh, okay.
And where did you find that, like, I guess I couldn't
Info?
figure out that concept.
I don't know. It just made sense that way. I didn't read it anywhere.
Oh.
I can't find anything right now about double-stranded RNA.
No, because that was in
Let me Google it.
dang it.
Yeah, it's,
Oh,
it's on
wait.
the instructor notes. Viral chromosomes.
It talks
Okay.
about double-stranded RNA.
Yeah.
Well, it also says viruses never have both. Oh, never mind. They contain either RNA or DNA.
Did Agnes ever text you back?
No, Agnes never did, which is kind of concerning. Paperclip accidentally.
I'm a little bit
I got nothing.
confused as to like, because last time I added her name to the, because she wasn't able to make it last time either. well, not last time, but I think the time before that, but I added her name on the little link still. Is that a, because I feel bad, because it's not like, I'm sure she's done her work, it's not like she, like, tries to miss it.
Yeah, last time it was because she said she was late. I don't,
Yeah.
This time she's not responding at all, so I'm not sure. We can ask her on the board, I guess.
Yeah, I just don't, I feel bad not including her name, because it's not like, I don't think that she, like, it's just hard to
Yeah,
get
I feel that too.
Yeah.
coordinated. But I don't know.
Yeah,
just
like
wanted
after
to
your
ask.
message of saying like Thursday between 2 or 8:30, she said I'm good for those times too, and so I'm like, okay, so we're all good.
Okay. I'll text her after and see if she wants me to put her name, what she wants me to do about it. But who wants to take 3?
I can take 3.
Go.
This question concerns the structures of chromosomes. A, the mouse version of chromosome 1 is 197 million base pairs in length. How long is the DNA portion of chromosome 1 in meters? And the answer is 0.067 meters.
That is not what I got.
That's the only one that I got out of all of them. So.
How did you do that?
How did I do that?
How did you set the conversion?
I took the base pairs, the 197 million,
Uh,
and I divided it by 10
okay.
base pairs, and that gave me the complete turns, that gave me the 19 million complete turns, and I times it by the 3.4 nanometers.
Right.
That's how many turns, and then that gave me nanometers total, and then I just converted that into meters.
I did the same thing, but I got it wrong. I need to review that.
On the answer key, it has it very short. So I guess I did it in a really weird way.
So what does it say on the answer key?
It says 1.97 times 10 to the 8th, which is the base pairs, times it by 0.34 nanometers above 1 base pair conversion, and then times it again by 1 meter at the top and 10 to the 9th power nanometers.
Oh, that's what I did wrong. I said, this is stupid. But I said 1 nanometer. My conversion was switched. 1 nanometer to 1 times 10 to the negative 9 meters. Oops. Okay.
Okay. So B then?
Yeah, for number 3. Yeah, should be.
Based on what we learned in class, how many nucleosomes are found on the mouse version of chromosome 1? Assume that the average length of linker DNA is 50 base pairs. The correct answer is 1.01 times 10 to the 6th power nucleosomes. I got that one wrong. So.
This one I don't understand. It says 1.0 or 1.01.
Because there's 146, because one nucleosome is 146 to 147 base pairs. So you take, I thought the way that I did it is I said 197 million divided by 147, that gives us the first number, and then I took the 197 million divided by 146, that gives us the second number. So it's like, it can be this to this many nucleus. But I got it wrong.
No, you did it right, but it's 196 or 197.
Base pairs?
Yeah.
So you have to do the equation twice. One for 196 and then one for 197, kind of like the quadratic formula.
Oh, is that what that's
I just thought it was an option.
What it looks like.
Okay.
It says to do them both.
I didn't realize that.
So where did you guys learn how to do this math stuff? Because what I know that in the reading I totally spaced out on looking out for the 0.34 nanometer part, but for everything else, how did you like find how to get from point A to point Z?
Honestly, I just looked at the answer key.
Okay,
'Cause,
no, because that's what I did too, and then I was like, Sister Mayo Mayo, I'm really sorry.
oh,
Okay, so on A, I just kind of tinkered around with it, I guess. I guess I try to use my chemistry in there and use the whole conversion factor, and I hated that. But
things in until they cross
yeah,
out.
B, it looks like I did it right, but at the same time, I used the wrong base pair to use because I thought I was supposed to use 50 base pairs. Because the average length of the linker DNA is 50 base pairs. That's what I thought I was supposed to divide it by. But I did.
Like the 50 base, the 50 linker, is that even relevant? Did they just throw that in there to trick us, or what the
the
heck?
what?
I don't know. Because it looks like it's not being used at all. Unless I read the material wrong.
Because that's what in C. Let's do C because I was a little bit. I haven't checked that answer either. But so there's a histone, and that's 196 to 197 base pairs, and then on each side of the histone, there's like linker base pairs,
Yeah.
and that's 25 on each side makes 50. But so I didn't know how to I figured that would apply to problem C, but I didn't understand how to apply it to C. So do you know that if it even came into play for C?
It doesn't.
Okay, well
It
that's
doesn't
good.
at all. They use the 196 or 197 base pair again.
Okay. All right. Sweet.
Okay.
That's not
So we're
bad.
gonna move on, or
Yeah, I think so.
Okay.
I mean,
the haploid human genome is approximately 3 billion base pairs in length. How many histones are predicted to be found within the haploid human genome? Assume that the average length of the linker DNA is 50 base pairs. The right answer is 1.22 times 10 to the 8th histones.
okay, hold on though. The haploid human genome. Oh, wait. Didn't it use in the instructor notes 146 or 147 for the
That's
base?
That's
Yeah,
what I thought this whole time is it was 146, 147, but
for the
Yeah.
human one, but for the mouse one, it's got to be different. But the human one definitely says. Maybe she did her math wrong.
we should email her.
Yeah, do you want to just email her? Cause even though I semi understand part 3A and B, 3C and D I was like tossing out the window. I don't give a crap anymore.
Yeah.
So the instruction in the instructor notes it says that the mouse is 196 to 197 histones, right?
But the human is 146 to 147.
Okay, that's why I got all those other ones.
So the mouse one should be 196 to 197 then, right?
I don't know.
Are we supposed to memorize that?
Probably.
F.
I know. Yeah, seriously. Ow,
Let me look in the notes real quick.
my leg hurts.
And by real quick, I mean maybe not real quick because it's just in this pocket.
Do we want to go over D, or do we want to just email her and say, hey, what's the deal?
Well, I just think the mouse one is right and the human one is wrong.
Yeah.
And then a typical human somatic cell should still be 146 or 147 for the base pairs then.
Do you see that in the notes?
Yeah.
Okay. Then I'm not even gonna look at these. Do you want to email her?
Me? What?
Do you want to email her and ask about that?
Not particularly. If I do, I won't do it tonight.
Okay.
But yeah, because I need to go to bed so soon. I have class again in the morning. But
I can email her, so that's fine.
Oh, great.
Okay.
I was like, I
She
can do it
probably needs
later,
to
but I'm
do
not.
that part of it.
It's enriched.
Okay. Should we go to 3D or should we just go to straight to 4?
Nice.
So D would be 146, 147 again, and not 190.
Yeah.
What?
And multiply it by 2 H3 molecules.
Yeah.
Yeah, so her answer should probably be wrong on there because it should be 146 or 147.
No. Three.
Yeah, we can just kind of skip it.
Alright.
Who wants to do 4?
It's not really calorie free or sugar free. It just has less than 0.5 grams per
Do
serving.
4.
So in the
Well, the list
serving,
several molecules that were discussed in lesson 6. I'm not going to read all this. Which of the following molecules above are nitrogenous bases?
So the guanine, uracil, and thymine are the ones that are listed on here.
Yep.
But
But would uridine
Like-
be one?
huh?
Uridine wouldn't be one? Oh, uracil, guanine, uracil, and thymine. Duh. Okay.
But I feel like adenosine triphosphate, because it was listed as an RNA nitrogenous base.
That
Oh,
was
it wasn't this.
nucleotide.
Yeah, it's the adenosine triphosphate is a nucleotide, but not a nucleoside. When they're referring to nitrogenous species, they're usually referring to nucleosides,
Oh. Okay.
like the big picture, basically. The nitrogenous base is like big picture, and then after that you have nucleosides, and then like where you get more specific, so whether it's a deoxy or just the whatever other name, and then you narrow down to the nucleotide, and that's when you do the whole triphosphate thing.
Oh, okay.
So like when we learned in like high school, where it's like the thymine, and then the guanine and all that, that's like the big picture.
Okay.
Yeah, that's why it's only those three. That's why it's not adenosine and the other ones.
Okay.
Which of the molecules above contain ribose?
So it says it's adenosine, guanosine, uridine, and adenosine triphosphate.
Yeah.
Okay. And then see which of the molecules above are nucleotides. I said adenosine, deoxythymidine, thymine, and uridine.
It says it's adenosine, guanosine, uridine, and deoxythymidine.
Okay. I gotta get back to this. Okay. And which of the following molecules are nucleotides? I said deoxythymidine, phosphate, adenosine triphosphate, and uridine diphosphate.
Yep.
Yeah.
Okay.
Cool. Now we can actually do 5 and actually talk it out.
Okay. So it says suppose a DNA strand has the following sequence. And it shows you the sequence. I'm not going to read that letter for letter. Okay, so describe what is meant by the 5' on the left-hand side of the molecule.
It's connected to the phosphate group.
Yeah.
That's why I said.
Hmm.
What is it says, located at the left-hand side of the DNA molecule above is the nucleotide. The base within the nucleotide is adenine with a free phosphate group attached to the 5' carbon. So that's basically the 5' and with the adenine is attached to the phosphate. That's basically what she's getting at, right?
Yeah.
Mm-hmm.
Okay.
Okay, the next one says describe what is meant by the 3' on the right hand side of the molecule.
Connected to the OH group. And it's the docking site for new bases.
And so yeah, thymine is attached to that one.
And with the free hydroxyl group.
Yeah.
Okay.
Okay, so are we good for C? I mean, like, are we good to move on to C?
Yeah.
So what is the sequence of the complementary DNA strand that would have the capacity to form hydrogen bonds with the sequence above? So you're just making so A matches with T, T matches with A, G matches with C, C matches with G, so on and so forth. And that one runs 3' to 5'. So, okay, I think that one's pretty easy. And then D, suppose the molecule from part C is able to form hydrogen bonds with the sequence above. How many turns of the DNA double helix would be found in this molecule?
That makes sense. But it's 2.5 turns.
Hold on, let me like see. Just a second. Okay, yeah. Yeah, it makes sense to me too.
Wait, what did we say for D?
It's 2.5 turns. There's 25 base pairs,
Okay.
and it takes 10 base pairs to make one turn.
Okay, I get it.
Yeah.
Okay.
Okay.
Cool.
Alright.
That wasn't terrible. I need to go back to the math though.
I need to review all this math crap because I'm not sure where I am anymore.
Never
There.
stuff fast.
Okay though. I don't know.
I was nervous as I was the last time.
Yeah, true. But still. It's gonna be hard.
Well, I'll touch on this and see what she wants me to do.
Okay.
I'll post this link too.
That's good.
Let us know if we can help with anything.
Okay. Been real.
Yep.
Yeah.
Happy night.
So boring. Okay. Okay. Bye you guys.
Bye.